In this video, we are going over the big ideas in the first chapter. So the first thing we did was something you should have done in grade 9, which is solving a linear system by graphing. We talked about the different ways to graph a line. You can use the x and y intercept to graph the line, or you can graph a line by using the slope and the y-intercept. Now, if it's not in slope-intercept form, then you have to convert it to slope-intercept form. But that shouldn't be too much of a problem. After you're really good at solving a linear system by graphing, we explore the different scenarios or the different cases that may take place when you solve a linear system. So you can have infinite solutions if the two lines were coincident lines. You can have no solutions to a linear system if the two lines were parallel. And you can also have one solution when the slopes of the two lines were different. So 1 and 2 really go hand in hand because once you're able to solve graphically, you can visualize the 3 different scenarios. It really makes perfect sense to introduce it right there. But we did say there was a big problem when you solve a linear system by graphing. Now, there were quite a few problems, to be honest with you, but there was one deal breaker that to me personally, it just makes solving by graphing not nearly as good as the 2 other methods we're about to learn. Solving by graphing is not accurate or potentially inaccurate, okay? If the solution does not occur where the grid lines intersect, I can't possibly tell you what the answer is. I'll have to guess around and I have to estimate the solution, which is something I prefer not to do, especially when I can solve it algebraically and get the perfect answer. So what are the algebraic techniques we learned? You can solve a linear system by substitution or elimination. So I won't say which method is better than the other. They're different, and I guess they both have their advantages. It really depends on the system. If a variable is already isolated for me, I'll probably use the method of substitution. But if a variable is not isolated, I'll probably use elimination. It really depends on the system. I have to take a look at it. But on the test, we may specify you have to solve by substitution for one question, or you have to use elimination for another question. So be comfortable. You have to know how to do it both ways. You can't just always do substitution for every single question. Okay. And then we did problem solving with linear systems. We solved these coin problems, investment problems, mixture problems, rate problems, all sorts of problems. I personally hate to divvy up my word problems because I can add a whole bunch of other problems. Okay, so on the test, if you see problems that don't fall under one of these categories, don't be angry. Okay, like the whole idea of problem solving is that you can read the problem, extract the linear system that corresponds with that problem. Okay, you need to interpret the sentences and build linear equations that make sense. So just get a good feel for that ability. Okay, that's what we're really tackling, as opposed to just focusing on a specific type of word problem. Lastly, we went over the 3 different cases again, but this time we approached it algebraically because I want you to be able to see when you have infinite solutions or no solutions when you solve by substitution or elimination. And that's essentially the first chapter, solving linear systems.